Hi, I'm going to go through the orb demo, which is a tiled uses Unreal Engine 4's world composition to import tiled worlds. This world is 8 by 8 kilometers in Unreal units or whatever, so it's very big, densely populated with vegetation. I'm just going to go through the tools and everything I used to create this. Let me show you a quick video that I did earlier of what it looks like. So there's a little orb flying around. You can control him as well, and he just explores the area. He has some special effects at various conditions and stuff, which we'll go through. The only problem I have right now is that the tiles are pretty slow when it loads a new tile, because one tile is 2 by 2 kilometers big. I need to make it smaller, so lesson learned. But yeah, it uses Unreal Engine's procedural foliage and grass, procedural foliage spawner and grass shader to render this. Let's go into some details. I used a very good tutorial or set of tutorials to achieve this from the Unreal Engine website. Just go to unrealengine.com, click on Learn and Documentation, and just hit World Composition. One of the links will be World Machine to UE4 using World Composition. This is the tutorial I used. I obviously used World Machine, I bought it. Only one thing to note, point number 5 under tiled build setup, flip y-axis orientation. I'm using Unreal Engine 4.9, the binary version, and it has this option when you import the tiles. So you don't need to do this. Or if you do this, you need to flip the switch when you import it. So yeah, I just followed this tutorial to get the tiled build set up or imported into Unreal Engine. Then for the grass, I followed the grass tool quick start. So in the documentation, just hit grass and you'll find it. It's all there. Easy stuff. I did not use any of the prerequisite or stuff from the market, but you can. It'll probably look a hell of a lot better than what I've done. Everything I've done I created manually. Obviously not the music or the special effects. And the textures are from CG Textures, but we'll talk about that in a second. So I just followed the tutorials to get the grass set up, and this is the procedural foliage tool quick start. I followed this for the trees, and then I also bushes as well, but then I also did it for the mountains. There are mountains in here, and these mountains, that was blurry. These mountains are mountain meshes. They're very big, and they're also generated by procedural foliage spawner. So that in essence the whole world is procedural, other for the actual landscape itself, and obviously the character mesh, the orb, and all the stuff that he's doing. I'll also explain what I did there in some detail. And I'm also going to give you guys this project. You can download it from my Google Drive. I'll give you the links, or I'll point you to the website to go, and you can just download it, source code and everything, including, you just need to use Unreal Engine 4.9. And I'll also give you an executable if you want that. It's pretty big, it's about a couple gigs. Right, let's get into it. I started with World Machine. I used an advanced Perlin. I think this is one of the default devices. Then I added a terrace. I also think that's it might not be a default one, but in any case, it's very simple. There are many tutorials on how to use this. It's very, very simple. You simply drag and drop them here from the toolbar and play with the properties. I didn't really play with them too much because I wanted to get this up and running pretty quickly. I did add some erosion, but that's also part of the tutorial if you follow it. Not this one, the one from the website, from Unreal Engine's website. The important things here are under your project world parameters, your tiled build options. Obviously your extents need to be set up for how big you want the entire world to be, and this is how big a single tile is. So this I would typically need to make smaller for the load times to be more efficient or better. And as you can see, I did not tick that flip y-axis orientation because the new Unreal Engine actually has an option for that when you import tiled worlds. This is an important number to remember, your maximum elevation. You need to do a little bit of math when you import it as described in the tutorial. Then the most important part is your outputs. They need to participate in when building tiled worlds. They need to be a specific format, or 16. And then you add these slope selectors. I used 3 for low, medium and high angles. So the terrain will be imported, and then I can apply materials to that landscape based on the slope angle of the terrain. I decided to go on grass for 0 to 18 degrees, sand for between 18 and 46 degrees, and rock for everything up to, well, from 46 degrees to 90 degrees. And then they are simply exported as well. They have to participate in tiled world builds, and they're exported as raw, in the raw format. Then you simply click well, let's quickly have a look and see. So when I go to the Explorer view, this isn't actually what it looks like. Don't click on I clicked on the device, so it was actually just showing me that device's output. When I go back, there we go. Let's go to a full view. So I've only got this little small section of this huge, endless planet of stuff. This little square here is 8 by 8 kilometers big, and this is what you get. So this is what will be imported into Unreal Engine, broken up into tiles. So when it's exported, it looks like this. You also need to, the slope selectors will export these weight maps. So Unreal Engine will use this, you will use this in your material landscape, and assign them proper names like grass or whatever you want, sand and rock. Let's quickly look at the landscape textures. These are some textures that I did previously, just using simple tiling techniques, combining various images and making them tile. And I just darkened it a little bit because I found the images were a little bit whitewashed when you import them, or when they render. Not when you import them, when they render. It probably could be the lighting, I'm not 100% sure. Then I also made 2 rock textures, and these will be used on the landscape as well as the rock and mountain meshes that are imported into Unreal Engine. I'm going to go through some of the vegetation models. These were created in Max previously for a previous project that I did. Haven't finished that project. Let's quickly have a look at some of these on the mountains. Just waiting for it to load. Just want to open up the level of detail. So all of them have level of detail in 3D Studio Max. I didn't actually end up using this one in this project. Let's just go and unhide some of the other ones. So here's one, for example. These were obviously, when I imported them, I scaled them up incredibly big. And let's just quickly have a look at some of the rocks. As you can see, they also have level of detail, so they'll have lower and higher polygons, so that I can change the material and control the amount of polygons in the scene based on the screen size of the mesh. And I just quickly want to show you the scatter rocks. There are some scatter rocks that are supposed to, just take off the grid, that are supposed to fill the grass terrain. All of these rocks will be scattered using the procedural foliage spawner at various sizes. Right, let's go look at some of the trees and bushes. These were done in SpeedTree. SpeedTree for UE4 subscription. The textures come from pictures that I took, so they're not really 100%. They could be better. This is one of the bushes. They also animate. They've got some animation based on the wind. I just want to open up a few others. Let's look at this guy. These were also done for another project. So I created these. There's quite a few of them, and then I just simply compile them. And these will get imported into Unreal Engine. I just want to show you the grass. The grass textures were taken from my garden as well, so they could be done a lot better. But that's cool. They do the trick. They also all of them sway in the wind, so they have wind animation or vertex animation. For the textures, when you export this or compile this from SpeedTree, you end up with a whole bunch of files. Some of these, well, I chose TGA for the texture format, but I had to darken these as well. So if I just quickly open up, and also for the lowest level of detail, I used Billboard. So when I exported, I told it to give me Billboard so that it's very, very low poly for the lowest level of detail. Because obviously this is a huge world, and I do want trees and bushes. I didn't show you the trees. I do want the trees to be visible for at least 75,000 Unreal units, which is very far. Let's just have a look at one of these guys. Also created a few dead ones. Dead ones just mean they don't have any leaves, but they follow the same principle. These could all obviously look a bit better, but it's fine for now. And the leaves have their own little, they do a little jitter, as you can see, which you won't get with the bushes. Well, you don't want to get that typically with bushes. So the textures I had to darken them a little bit. Let's just quickly look at one. Because when I import them into Unreal, it was too whitewashed. And it was really, really light. And I'm using dynamic lighting. There's no baked or static lighting in this huge world. It's definitely not something you want. It will ruin your life. And I also want day-night cycles. So in this demo I didn't do that, but you can't do that with baked lighting. So let's look at this guy. When you compile from SpeedTree, it creates atlases. You can specify the dimensions, but it creates atlases for your textures. These textures are from CG Textures. There's one that I've darkened. Yeah, because they were just too bright. Yeah, I just simply darken them in Photoshop. Here's an example of the billboard, and you can see there I just really darkened it out. I was looking for this guy undarkened, but I can't find him. Here he is. Obviously they have masks, so that's why this background is white, but I just filled it with a darker color as well, just habit. Okay, so those are the textures. Then I'm just going to go through the character mesh. We'll get to a few other things, well, Unreal Engine and all that very soon. Just want to go through the character mesh quickly, how I created him. It's a very, very simple mesh. I created him using Maya. Nothing special. It's just a sphere that in Max you would call this beveling, but in Maya this is extruding. So I was just extruding a few faces around to get this. I had to give him a bone to make him a skeletal mesh, because your characters have to be skeletal meshes in Unreal Engine. This bone, obviously, this mesh has no animations whatsoever, but in order to I had to bind him to a skeleton, so that's his skeleton right there. His textures we'll get to in a second. I just want to show you his UVs. Not incredibly. This was just auto-mapped. Using Maya's auto unwrap feature, so nothing spectacularly special. And then export it to an FBX. Then for the mesh, the mesh textures, I used Substance Painter and Substance Designer. Let's go look at Substance Painter. I have two materials assigned, one for the eye, which is this, not really an eye, it's a square. And then the rest of his body is a nice scratched metallic and very reflective material, and you can see this reflection all the way through, even in the game. You can see I'm not sure if his glow sphere is interfering, but you can see his body is very reflective. So it reflects the environment around him, which is really cool and very easy to do with Substance Painter. So these textures were then exported and imported into, and these are the textures that were exported. So you can see they're very plain. And I'm following PBR, so physically based rendering, with base color, height, metallic, and roughness. Well, and normal as well, but yeah. So these were then imported into Substance Designer. Just going to drop the mesh in here. So his eye and his body. And then these were exported or published to an SPSAR file, so that I don't have to redo those or set that up in Unreal Engine. The SPSAR file is imported into Unreal Engine, which we're going to go to right now. Let's start with the quick demo. Might be a little loud, so I'm just not going to talk for a few seconds. I'm just going to play it. And there at the end you saw the meshes disappear. I hooked up a level blueprint to this game, or I'm going to call it a game, so that you can control the graphics. So that you can control, and this was done in the persistent level. It's very important that the level blueprint is done in the persistent level, because the persistent level is persistent throughout all the tiles. Each tile is a map and streamed as you're playing. So be careful of what you put in your persistence level and what you put in your other levels. If you put your player start in one of the tiles, it won't work. And your game just will give you a black screen. You have to put everything that you want persistent throughout the whole world must be in the persistent level. So these are just simple commands that I provide. If you press 1, 2 or 3, it just simply changes the scalability settings. These scalability settings you can get from the Unreal documentation. Very simple. And then escape key just simply quits the game. Otherwise you had to Alt F4 or plug it out from the power source. I just want to close this guy. Then let's just go through the tiled imports. Let's start there. As you can see, these were imported, so there are the 16 tiles. I chose to put my player start in this tile, an arbitrary place. I'm just going to disable a few things because we'll talk about them as we get to them. Okay, so let's just zoom out here and have a look. This is one tile. I'm going to open up another one. Let's open up this guy. So even when you're playing the packaged or published product or version of the exe, it's still, when it comes near to the other tile, it stutters. Depending on your graphics, it can stutter more or less, which isn't great. But you need to make your tiles smaller. So lesson learned. The other tile, you can see on this side there's one, on this side there's another. So there are 16 tiles in total. Let's have a look at the world composition. How is this world composed? So there are the ones that I've opened now, these two, and my world, or this map is, or this world is comprised of this lighter colored area here. So all of these would be tiles, and it gives you the details as you hover over them. These aren't loaded into memory, so they're not being shown now, otherwise your machine would probably explode. Okay, so that's, and this is imported from the tiled or raw data from World Machine. Now let's go through the landscape material first and see how did I do the landscape material. It looks very tiled from far, but generally there's fog and all sorts of things enabled. So when there's a lot of trees and mountains and things, you don't really see the tiling that easily. The landscape material. This is all done using the same principle as that tutorial. The landscape coordinates control the tiling. I've set this to 25, which is pretty high. So it looks pretty good when you're close to the landscape. And then here are my 3 textures that I chose to use for grass, for sand and for rock. And then I'm using layer weight nodes. And these layer weight nodes are the same nodes that I've assigned to my weight nodes from the tiled world, or the tiled import. So if you just follow the tutorial, they'll show you how to do that. It's very simple. Then this is the grass. So the grass is I think it's a foliage type or something like that. or grass output. So this is what's rendering the grass on the terrain. I've broken it up into 2 layers. I want the grass to render on the grass and the sand. Wherever the grass and sand materials appear on the landscape, I want different grass types to render. I'll go through how I set up these in a second. And these are set up using the procedural foliage type stuff. I think this is a landscape grass type or something, but it uses the same principle, which we'll go through in a second. Let's go look at the grass mesh. So this was imported from SpeedTree. Level of detail, I created different materials. All of them are material instances which have a parent. The parent uses some interesting shader components or functions. I added a lighten parameter so that I can lighten or darken the textures, which I didn't do before in the previous project. That's why I had to darken the textures using Photoshop, which I won't need to be doing again. And then you need this for your Vertex Animation. You need to, SpeedTree will import this automatically. One note, don't try and import multiple SpeedTree models at the same time. It won't work. Import them into their own folder and everything will be fine. Something about shared materials or whatever. Then for the lower level of detail, they're also material instances, but they don't have normals assigned. So in the parent class, it's simply doing the base color and also exposing the lighting parameter. So you can see, and then the billboard is exactly the same thing. The billboard parent material, it's a material instance with the parent material. The billboard does have a normal map because you want your billboard to have a normal map. Otherwise, when you get really far away and it doesn't have a normal map, it doesn't look right. It looks funny. It really doesn't look, you can almost just see it's a bunch of quads. Then for the grass procedural foliage stuff, we use this landscape grass type, which if you follow this quick grass tool quick start, they'll show you how to do that. So then you set up some details here, and this object right here, or this actor right here, is the one that is referenced in the landscape material. So that's the same guy. So here you can set up how dense do you want it, all sorts of settings. The culling distance, I definitely played around with this because I want to try and have this run on low-end graphics cards, and it sort of does. If you press the 1 key and get it to low graphics, it'll still run. I ran it on an entry-level graphics card and it worked, so I was very surprised. So you play with all these settings to get the kind of look you want. I'm still combining 2 meshes here. One is more dense than the other, so you'll get a lot of green and a little bit of brown for dead grass on your grass layer, and on the sand layer I did the opposite. The green grass is less dense than the dead grass. So I'm going to just enable the grass, and that's the culling distance that you see kicking in there, and those stripy things are the level of detail. So if we go to Vertex, as you can see the Unreal Engine's tessellation on the terrain working so well. It is amazing, truly amazing. Anywhere you go, you're going to be seeing grass where there's grass on the landscape, and because I've added a wind source, there's 2, interesting. Because I've added a wind source, the grass is blowing. The vertices are animating. Because when I imported this from SpeedTree, I told SpeedTree to include wind animation. And you also need to tell it in your material, not your low-level material. You also need to tell it in your material to use the SpeedTree node for ambient occlusion. Yeah, very cool. So we can go anywhere and there'll be grass. So as you can see, where there's more sand, there's more brown or dead grass. Okay, that's it for the grass. Let's have a look at the trees. And the rocks and the bushes. Trees, the setup's pretty much the same as any SpeedTree asset. You have your bark, branches, you have your leaf materials. Set up your LOD. For the very lower LOD, I'm using low-level materials once again. They're instanced, so they don't supply any normal information. And lastly, your billboard. I like to use billboards. Some people don't. Obviously, it looks a bit weird, but I actually do like it. Because the further away you get, it really doesn't look that horrible. Then once you've imported your trees, you need to set up your procedural foliage types. Now these types are going to be used in your procedural foliage spawner as described in the tutorial. Procedural foliage tool quick start from the Unreal Engine documentation, which is amazing. Right, so what the procedural foliage type actor does is it tells the procedural foliage spawner how to spawn, or how to, it thinks of itself as planting seeds and spraying and growing. It's really complicated and really simple at the same time. So I'm obviously using quite a few values here, not in this particular asset, but some of the other ones which we'll get to. The slope angle I use a lot, so I want this bush type mesh to spawn wherever this slope applies, or wherever it finds the slope. I'm ignoring all landscape layers, so it can grow anywhere on the landscape where the slope applies, but remembering I exported this landscape using weight slope nodes from world machine, so I know this would be on grass typically. And then I'm just scaling it up slightly a little bit. I think this might even be the default between 1 and 3. But I really had to play with these values quite a bit. Especially the collision radius and the C density. You have to play with those to get the effect that you want and to not kill your machine. Let's quickly look at one of these other guys. I think that's pretty much the same setup. We'll get to the rocks in 1 second. Let's look at a tree. Okay, so those also follow the same. I think they have a higher collision radius. I didn't want the trees to be so dense because I'm using dynamic lighting. I'm also using a light propagation volume. And when you walk underneath a forest with the dynamic lighting, it's pitch black. Unless you probably go and add some more dynamic lights to your camera or whatever, which I didn't do. I didn't need to. So these guys go into a procedural foliage spawner. You simply add them as elements. I didn't change any of those values. The seed tile size, you can play with that. And this guy was then inserted or dragged into the level. You don't do this in the persistent level. That won't work. You have to do this in the tile that you're working in, obviously, because it only applies to this tile, and you have to scale and size it up to fit your scene, which I'll show you in a second. I just want to show you the mountains and the rocks. Let's just quickly go through the mountains and the rock meshes. I'm just going to show you one. They're pretty boring. Everything uses collision, so everything has collision attached. I didn't create UCXs in Max or in Maya, no, Max. I let Unreal auto-generate collision. Typically I don't like that. You should be generating your own UCXs because their collision the algorithms aren't that great for walkable meshes. For just crashing into stuff, that's fine, but if you want to walk on this rock, you're going to be floating in the air, which is crap. Same thing, it has different level of details. I control the level of detail myself manually for all of the meshes to get the exact effect that I want. And the nice thing is, once you've spawned something on here, you change it in the mesh, you change the level of detail settings, it's immediately visible. You don't need to re-simulate the entire spawner. It's dynamic and it's really great. Not using any baked lighting. The mountains were tricky. The first thing I did was I imported the mountains from Max as they were, tiny little mountains, and then I went into created a mountain foliage type for them, and I set my procedural scale value up to like 50 or whatever, and it didn't work. It gave me like 2 meshes and a bunch of errors. Scale your meshes up when you import them. Simple. So this guy is scaled up more or less to where I want him. The only thing is now, if he's going to be size 2, he's going to be twice as big as he is now. Which is interesting. Their level of detail set up pretty tight because they're always big. So I made it for the lowest level of detail 0.7. You don't lose that much. But you do see the transitions more. The Unreal Engine has built-in screen door fades, and it looks amazing and it's great. Thank you. But you probably want to play with these settings a bit more if you're going to be doing this for production. But it's completely usable. So then I created procedural foliage type actors for the mountains. The rocks were linked to the same procedural foliage spawner as the trees. So the trees, bushes, rocks, and scatter rocks are all in here. As you can see, trees, bushes, and there are the rocks, and there's some scatter rocks there. So they all scatter across the terrain along with the trees, and they use the trees collision, spawner collision values, etc. For the mountains, that didn't work because my mountains are huge. So I had to play around with this. Obviously, I want the mountain to sit in the terrain. It mustn't just look like it's floating above or whatever. So these values are important. The align to normal, I didn't really play with that too much. Then the ground slope angle for the mountain is very important. I don't want any mountains where I'm supposed to be walking, so I had to play with these values. I decided on anything up and above 35 degrees. It will place mountains. And then the scale values, I made it a little bit smaller for the minimum and 1 for the maximum. Now, just a quick note on the trees. I'm using landscape layers for the trees because they were growing on the rock. So I told them at least grass 0.5, and if there's sand, it has to be at least 0.5. So it stopped growing on the rocks. For the bushes, I don't care. So then I created a procedural foliage spawner for the mountains, and these are the mountains in here. So I'm going to enable them, and then everything's just going to pop in. Let's just re-enable some of the stuff. Some fog. So I'm going to just get out of here and go really far back. The level of detail, the culling distance and those things. The culling distance you can set from the spawner itself. Now this spawner, you have to drag and drop. Once you've created it, you drag and drop it into your tiled world. And then you need to tell it where you want to spawn your stuff. So I'm just going to go to let's go to a left view, just to give you an idea of the size. That's your sky sphere right there. Huge. and this is the terrain. These are 2 tiles, and there you can see the trees and the mountains were scaled to the same size in all of the dimensions. Also, a side note, if you do this, you have to enable this is all in their tutorial, you have to enable your world composition. Your kill Z needs to be infinitely low, unless you know exactly how low your terrain goes. My terrain that I imported here is massive, it's huge. So the character kept on, the game kept on stopping because the character kept on dying because he was running down a hill. And before he was an orb, he was the little blue guy from Unreal Engine, and he would just die. So remember that. That's quite important. So the most important stuff here is scale your procedural foliage spawners to the size of your whole level. You can always go and add in places where you don't want foliage to spawn for your static meshes, because typically this would be the raw world. And then you would go and build your stuff in here, your buildings, your roads. I'd love to do roads. My next game isn't going to be needing roads. Well, I'm not going to be using this either. It's going to be underwater, but still, it's good to do. So I'm just going to zoom out a little bit here and zoom back in, give you the idea. And then we're just going to run through the character, set up and all that, and then we're done. So as you can see, the culling distance for the mountains and the trees are very, very, very far, because you need to see them very, very far. Makes sense. And then you get a little bit closer, you start seeing the bushes. You don't want to be seeing grass now. That would be immensely expensive, even with billboards. Now these are all billboards. You'll see it there. We start seeing some billboard grass. Let's get a little bit closer here. See, that one just faded into some more detail. All of these start fading into more detail. And let's get really up close here. And you can see that I've also made sure that only the higher level of detail for the first 2 levels are animating. I don't want my grass over there to be animating. It's expensive. And the more stuff you have in here, the less you're going to notice it. Obviously these meshes aren't 100%, like great, like wow, AAA. But this is what we do. So I'm just going to fly out here, fly over here, come to the top of the hill. Just going to settle down here. That UV mapping is terrible. My bad. It's very dark. I shouldn't have darkened those textures so much. Lesson learned. And I have to say, Unreal Engine is amazing. They've really done a good job. I did this in CryEngine before, but not with tiled worlds. I haven't found a single thing to complain about other than my skills. Alright, let's move on. Let's run through the character. From an Unreal Engine standpoint. Where do we start? Let's start with the code. Alright. I think this is the only custom class that I added here. This is almost a direct copy of the standard character that you get with the blueprint third-person C++ template. So I literally copy-pasted a lot of their code. I don't know why I didn't just change that one. I was scared maybe I'm going to break something. And that's why I keep so many backups. I break stuff all the time, and then I have to unrar it again, and it becomes a pain. So I didn't want him to be AI. I simply wanted him to move around, and that's why I enabled his tick event. So everything happens in the tick event. You can still just go ahead and plug in a controller or use your mouse and keyboard and move him around. It'll work, no problem. It'll work. I wanted some events to let Blueprint know something's happening. So when he adjusts his speed, Blueprint needs to know about it. When he changes his direction where he's looking at, Blueprint needs to know about it. Not every single frame, just once. This is just a once of, oh, I'm adjusting my speed. Oh, I'm about to turn. That's it. Not every single frame, because you want to be spawning emitters here and doing things. You don't want to do that every single tick. Your machine will explode. And then I made this little stuck event because he was getting stuck, and that's fine. The stuck event we'll cover quickly in a few seconds. Then there's nothing majorly happening here. The important thing here is the primary actor tick, canary tick must be true. It auto generates this. If you're going to copy paste it from another class, it won't have it in there. You have to enable it by default. As far as I know, I'm handling hit events. I'm handling hit events in here for reasons we'll get to. In the tick event, if he's getting hit, he goes up. He just decides, I'm getting hit, I'm moving up, I don't care. And then there are a few settings here. So if the last time he was hit is greater than 15 seconds, he's going to be moving really slow. And if the last time he was hit is greater than 5 seconds, he's going to be moving, he's going to be moving pretty fast. That's moving down. So if the last time he was hit is greater than 15 seconds, so in other words, if he hasn't hit anything in the last 15 seconds, he's going to start moving down because he's probably up high in the sky somewhere. You don't want to be using your Y's, your scene up or Y, to check how high is he, because your terrain is massive. It's really massive. When it's 10,000 now, it would be 100,000 later, and you're still only just below the grass. So you can't use hard-coded stuff like that. So if he hasn't hit anything for 15 seconds, just go down really quickly. If you haven't hit anything in the last 5 seconds, he goes down really slowly. So he just slowly, gradually goes. Now this is combined input, so you can call these are meant to be called in a tick. So you can call these as many times as you want. They get accumulated. So it's going forward. He's always going forward, and then he can go up or down while he's going forward. And you can override this from the keyboard and the mouse. You'll start arguing with him about where to go, basically. And then every now and then he decides to change his movement speed, and then he just lets you know, hey, I decided to adjust my speed. And this is useful for a few reasons we'll get to. It's useful for graphics and sound. And what are we doing here? If he hasn't, so if he hasn't been hit in the last 15 seconds, he goes forward really slowly. But once again, these are combined. Otherwise, he moves forward at his move speed. So if he hasn't been hit, he starts moving really slowly forward and down, where it's obviously really fast. And otherwise, if he has been hit in the last 15 seconds, he'll move at whatever speed he chose last. Right, then if he's not turning currently, we're just incrementing something there. So if he's not turning, there's a little random timer here. All of these are basically random timers. If this random timer he gets hit, he's going to decide to turn. Now all these functions that he's going to be calling here, we'll get to that in a second. Then he reinitializes the timer. He calls the blueprint event look at adjustment to tell him, oh, I'm deciding to turn now. And then he gets gets a random turn rate. Make sure that it's not 0, because you want to be turning. And here he actually turns. Now all these functions, turn at rate, move forward, all these functions are the same functions that you get when you copy it from the example code or generated code. And all it really does is it sets up where you're looking at right now and go in that direction. So you're always going where you're looking. That's the idea. And this where you're looking normally gets determined by the controller. So in this case, if you just leave the controls alone and he turns, you're actually telling him, hey, I've given you controller input turn. I've given you controller input go forward. And you can call this in the tick, so that's pretty cool. There's no overhead. You just don't want to be calling the blueprint events like this every tick. That's going to explode your machine. If you spawn an emitter every tick, you're going to be sorry. And then he needs to check if he's stuck, because I suck. I'm not using nav mesh, etc. So if you're stuck, if you haven't moved at least 50 Unreal units within the last 10 seconds, just let me know. That's all you need to do here. I don't want you to try and unstuck yourself, because that's not your job. Your job is just to let the blueprint know, hey, I think I'm stuck, and randomly decide to tell the blueprint, hey, I think you should be stuck now. The reason for that is this is a cool effect in the blueprint that what happens, which I'll show you right now. So I'm not using this function actually. This is copied from the example code, and then all these functions are copied from the example code. And that's how I did the up as well. This move up. You just apply the vector you want to move in. I'm using the up vector because my world up is always going to be up. He doesn't pitch. He only yaws. All right. Let's go back to the character here. So then I extended him as a blueprint. Here he is. I imported that mesh that I created in Maya, and you see him here. And he has two collision components, but this is his main collision component that determines where he gets hit and how he can move, etc. Things like that. Not how he can move, but this is his collision component. So things generally can't penetrate this sphere. It's actually a capsule, but if a capsule's half height and radius is the same, so it becomes a sphere. He has some events. He has hit events that I do use. I bound the hit event in the C++ for another purpose, but in Blueprint he's also bound to the hit event. And it doesn't matter in which order they get called, because they won't be talking with the same data, or they don't collide with each other. They perform very different functions when they're hit. Just quickly I want to show you the glow sphere. This material that I'm using, he's got a little glow sphere around him. This material was created, in this case it's an instance. Now this instance parent was created from the starter content water, but I modified it extensively. Oh, not really extensively. I got rid of all the stuff I didn't like or didn't need. I wanted an effect like this where it looks like he's shimmering or glowing around. So that was the water crest. So I mainly focused on the water crest. And I added a rotator. So it's rotating this material here, and it's panning this material here at different rates on X and Y, or U and V I guess, but let's stick to X and Y. Then you multiply those the red component of this is a grayscale, so it doesn't matter. You multiply the red components together. This is the basic way that they do it. They clamp the value to make sure that it's between 0 and 1, and this gets fed in as an alpha for the water base color, and then the water crest color, which is then linearly interpolated between, using that alpha as the value. That gives you this here. Then I made it slightly it's slightly transparent, so I had to change this guy to be translucent, and he's not really that rough. So yeah, parameters. These were already parameters. I'm only setting. I can play with the water crest color to change, because I wanted to change the color of this glow of this that he's got around here based on a few things, which I'll show you now. That's it for the character mesh. There's one more thing. I created a little sphere component here at the bottom. It doesn't use collision, so there's no collision, but it does use overlap. Well, it uses collision, sorry, but it doesn't block. It's not blocking collision, it's overlap, and I want the overlap events. I want to know if there's something below him in this region here, which I'll show you why now. The next thing I did was, in the construction script, you have to get a reference to his material. So I'm getting a reference to the glow sphere, which is the little glow sphere there with that funky glowing material. Create a dynamic material instance, set a parameter from a created a variable that I created here, so that I can change his color. And then there's a little reset function that I created here. It just simply sets the color of this parameter named watercrest color to the default value. And let's run through the event graph, and then we're done. This is the overlap. The overlap for this can stuck sphere, which is here at the bottom of him. I'm just setting a variable. So if he's overlapping something, set this variable here to true, and when you're done, set it to false. Alright, if the capsule component gets hit, this fires here. So on component hit, this fires. So this spawns an emitter at the location. This emitter here can spawn very frequently, but not in the tick. Doesn't spawn in the tick, but it can spawn in the collision loop. This is a once off, so it only loops once. I modified the starter content spark cascade or particle emitter. Sorry, this UI is called cascade particle emitter to only loop once. I think you do it under spawn. Where is this guy? Required. Come on, there we go. Emitter loops 1. So all of these would be set to 1. So it only does a one-shot deal, and then it's gone. So I spawn it. I provide the spawn point based on the hit result. I create a I want to orient the spark so that it looks like it's coming from the point where he's hitting the surface. Not that it mustn't look like it's coming from him. It must look like the thing that he's hitting, which it does. So use the impact normal, use rotation from X vector, plug it into the rotation, spawn the emitter. Auto destroy is on, so once it's played through, it's done. Auto destroyed, and it should be garbage collected and destroyed, whatever. And then I play some sounds. These sounds come from free sfx.co.uk, and some of the background music and explosion sound, which we'll show you in a second, come from the starter content from Unreal Engine. So it plays that sound. I only need the location, and I just vary the pitch a little bit so that all the sparks don't sound exactly the same. This sound itself, all of them are pretty random, so they have a little randomness to them, so that you don't hear the same sound playing over and over. And then I just simply change the color of his little glow sphere to red, and this delay 5 seconds doesn't mean it's not going to sit here and wait for 5 seconds. It's going to create I don't know how to say it properly, but this is going to still be running every tick, and he's going to see after 5 seconds from you calling this function, it's going to call this. So this is still going to be running every tick, and it might even do this again. It might even come into these functions and do them again. But it'll remember, I was in a delay. I haven't waited 5 seconds. Oh, I waited 5 seconds, bam, reset the glow material. So you can safely call delays in your hit events or your tick events. It's not going to slow up or hold up your tick event. Then this event is built from C++, so I'm calling the event speed adjustment to tell him I'm adjusting my speed. And all I really want to do here, I have a little hover sound. I'm just adjusting the pitch based on the speed that you're moving at. Similarly, when I raise the look at adjustment function from C++, when I raise that event, I handle it here in Blueprint, and if his this normalized value is actually the speed at which he's moving at, not the rotation rate. So if he's not moving, so if this is less than or smaller than 0, he's not moving, which is true, so then it will stop the rotate sound. Otherwise, it's going to play the rotate sound using the pitch from the speed that I've provided. And then I also, when he's turning, he gets his color tinted. Sorry, I had to take a glass of water. His color tinted to green. Wait 5 seconds again, reset it back to the default color. And then the last An interesting event is the stuck event. So because he was getting stuck and because I thought it would be cool, he's just going to spawn an emitter. This is an explosion emitter. It's unmodified. It comes standard with the starter content with Unreal. At the place where he's hit, then simply play the explosion sound. That's also standard with Unreal Engine. And then add an impulse to the actual character. So he's just going to fly off in some direction. I create a random unit vector, scale it up by 50,000, and I tell it use the mass, include the mass. The mass is set in the character movement component. I think it's defaults to 100. There it is. So it'll take that into account, and off he goes. So he's just going to fly off in some random. Oh yeah, but he will only do that. If this stuck overlap is true, and that stuck overlap gets set true when this sphere down here, this little stuck sphere, is overlapping with something. So only if he's close to the ground or hitting something underneath him will he do this. I don't want him to randomly shoot off when he's high up in the air going into who knows where. And then I'm just changing its color to yellow when he does that. Wait 5 seconds, reset the glow material. And that is it. That is all he does. So I'm just quickly going to play it once more. And then, yeah, thanks for listening, if you did. Cheers.